Leetcode problem 146 LRU Cache. Yeah, so let me first explain this problem, and then I'm going to explain in whiteboard about what kind of a data structure I'm going to use, and then I will write the code in the code editor. Yeah, so first, this is a LRU cache. LRU cache means least recently used. Yeah, this means inside the cache there are some values. Yeah, for example, this is a cache. Let me write a cache. So yeah, I have a 1 to 2. This is my first value, and 2 to 3 is my second k-value pairs. If I already visited this k-value pairs 1 and 2, yeah, it means this is value is most recently used, and this 2 and 3 is the least recently used. Yeah, so if I exceed the capacity, for example, I want to add another k-value pairs. For example, it is 3 and 4, but the capacity is only 2. What should I do? Yeah, I should first put this 3 and 4 inside. And where should I inside? At which place should I put it inside? Because if I put it inside, it should be the most recently visited. And then this is 2 and 3 is the least recently visited. I need to take this 2 and 3 out and put 3 and 4 inside. Yeah. Yeah, but our dictionary is not ordered. If we have an ordered dictionary, it is okay. But I'm not going to use ordered dictionary to solve the problem, because for this problem, I'm going to use a doubly linked list. Because if we have a doubly linked list, we can easily to imply this get and put function to deal with the recently visited or most recently visited or the least recently visited. Yeah, let me go to the whiteboard to explain why I'm going to use this kind of a data structure, I mean doubly linked list with cache. Cache is basically a dictionary in Python. And then I'm going to write the code in code editor. Yeah, and there may be more than 60 lines of code. Yeah, it may make any kind of mistakes, but I'll debug it. Yeah, because this is also for the real situation. If you are writing, more than 50 or 60 lines of code, it may have some bugs, especially for this kind of a linked list problem. Yeah. Now let me go to the whiteboard to explain the data structure for solving the problem, and then I will go to the code editor to finish the coding. Yeah, I already draw a doubly linked list. Now let's just go to the doubly linked list, and I'll explain what I'm going to do. After that, I'll go to the code editor to finish the coding. Yeah, so this is the doubly linked list I'm going to use. So for example, if we have an empty doubly linked list, we only have head and tail. Yeah, this is a head from the left side, and this is tail from the right side. And our capacity, C, is only 3. Yeah, if we were to insert a node, so this 2 means the k, and the value is 6. Yeah, if we were to put the k-value node, this is a k-value node inside, at which position we should do? We should first define our most visited node and least visited node. So I will always define the most visited node at the right side next to the head, and the least visited node at the most visited at the left side. This is the left side, and the least visited node at the right side next to the tail. So this is the least visited node, and this is the most visited node. So for the first node, if I were to insert this 2 and 6, 2 is k, 6 is value. So if I were to put this node inside, I just put it inside, because anyway, this is also the least visited or most visited. It's the same. If I were to put another one, 1 and 4, I should put it at this position. it should be next to the head because this is the most visited. If I were to insert another 1, 2, and 3, I should put 2 and 3 node at this place next to the head because this is the most visited. Yeah. Next, if I were to insert another node, maybe this node is, for example, it is 1 and 4. What should I do? So this is what we are going to use the put method. If we are going to use the put method to put a 1 and 4 node, so this 1 is k and 4 is value. If we were to put the inside, so first of all, we're going to put it at the place next to the head, yeah, and then connect it to this 3 and 2 node. After that, what are we going to do? We're going to remove this least recently used node. So this is basically the function of LRU Cache. We should remove this one. Yeah. And if we want to get a value, for example, we want to get a k-value pair. If we want to get a k of 1, and then we want to get the value of 4, take this node. Yeah. After visited this node, this is our get function. After we use the get function, we should also take out this node 1 and 4 and move it next to the head. Yeah. So this is basically what we are going to use. We're gonna have a doubly linked list, and we're also gonna have a cache. So this cache is used to store k-value pairs. So k is the k, our k inside the description is a number, and the value is a node. So inside the node is a doubly linked list node. Inside the node, there are also k-value pairs, and there is also previous and next because it's a doubly linked list. Why we use a doubly linked list? Because we can use the get function and put function in O1. We don't need to loop through the list. Yeah, if we need to take out one node, just take it from the tail. Yeah, if we need to put it to the most visited position, we just put it next to the head. Yeah, this is just O1. And also, we use cache because cache is with O1. Because k-value pairs, we can take a k with value. It is also O1. This is why we use cache plus doubly linked list. Yeah, now I'm going to imply this kind of a method to my code. Yeah, now let's go to the code editor, try to finish the coding. Yeah, this coding is a little bit longer than even hard problems, because hard problems is not so many lines of code, but this problem may be seen as a hard problem because there are more than 60 lines of code, and it's really difficult to write bug-free code for this problem. Yeah. Now let me define the node. As I said, we are going to use a doubly linked list, so I'm going to define a list node. Yeah. So for the list node, I'm going to use the def inside function. Inside class, we can use this init with the self and k-value pairs. Yeah, why I need k-value pairs? Because I want to connect this k-value inside the doubly linked list node to the k-value inside the dictionary, inside my cache. I want to connect. So the k should be initialized as 0, and here I will use a val should initialized to 0. And inside, I'm going to use a self.k should equal to the k, and self.val should equal to my val, and self.previous should equal to none, and self.next should equal to none. So this is basically the define of the doubly linked list node. Yeah. Now I'm going to prepare my variables for this class LRU Cache. So inside of the init, I'm going to define some variables. So first of all, the capacity should self.capacity should equal to the capacity inside the function. And I'm going to define another variable self.size because I'm going to check if the size exceeds the capacity or not. It will be initialized from 0, and I'm going to define a cache. So the class will be a dictionary. Then I'm going to prepare self.head and tail, because from the beginning I'm going to prepare some dummy node. This is just for easy calculation, for easy operation for the doubly linked list. So self.head equal to self.tail equal to this list node. Yeah, the list node I defined. So I'm not going to put any value inside because it doesn't matter. It's just a dummy node. Yeah. Let me go to the whiteboard. It means here I just prepare a dummy node for the head and another dummy node for the tail, and then I'm going to put the node inside. If I use the put function, if I use get, I need to get the k value pairs. I use the k to get the value for the node. Now let me write the we should also connect to the dummy node. So the self.head dot next should equal to self.tail, and self.tail dot previous should equal to self.head. Yeah, I'm not sure if I defined all the variables, but let's write the get function. If I need any variables, I'll put it inside the init. Yeah, basically I think it's enough for all of the operations of get and put, but let's just do it. Let's just do the get function first. So for the get function, we need to check this k value if it is inside. Yeah, if k not in self.cache. So here I imagine I've already put some values inside, so I just need to use this get function first. Yeah, so if k not in self.cache, so it means we're gonna return a -1. This is what we are told. If not exist, we're gonna return -1. If it is exist, we're gonna get a node. Here, for the cache, the k value pairs, k is a number, as I said before. The value is always a node. So the node is self.cache and takes the k. So I get the node. What am I going to do with this node? I'm going to take this node out and connect it next to the head. Basically, it's here. For example, if it is this one, I'm going to take it out and connect it to the head. And with this first node, this one, yeah. So there are two steps. But I'm going to use a function. So this function will be called, So here I'm going to write a function. This function will be called move to head. This move to head means I will take out that node and move it to the head. And add it to the head. So I'm going to take a node variable. So the node is this node. After that, I'm going to have a return. The return will be node.value, not.val, because this is my list node. I have a val. And why? Because here, if we use a get, we're gonna return a number. It's not a node, so we have to return node.val. Now, this is basically the get function, but we didn't write our API yet. We should try to write this move to head function. Now let me put it just below the put, and self.move to head. I will take a node. So there are two steps. For the first step, I'm going to use another function. I will disconnect this node. And inside I'm going to take this node variable. After that, I'm going to write another function, self.add to head, because I'm going to add this node to the head. I'm going to take this node. Why I use two sub functions below this move to head? Because this add to head will use 2 times. I will explain later why I use this for 2 times. And then we're gonna write the sum functions of self.connect. Now let me write self.connect. Let me define the disconnect node function. So let me define the self.net first. Define the self.disconnect node first. So the disconnect node should be here, a def with disconnect node, and inside I'm going to still take this node, and what we are going to do, we just need to disconnect this node. So for example, this is the node 1 and 4. We are going to disconnect. How should we disconnect? So this is the node. So the node dot previous, it is this node. Yeah, it is this node. Node dot previous dot next, it should point it to node dot next. Node dot next is this node. Yeah, so node dot previous dot next should point it to node dot next. Yeah. Now let me write it from the code editor. So inside the function, node dot previous dot next should equal to node dot next. Similarly, node dot next dot previous should equal to node dot, yeah, let me think. Node dot next dot previous should equal to node dot previous. This means we've already disconnected with this node. And also we need to write another function, add to head. And for the add to head, we can write it here with a definition of the function with a def, and here we're gonna write the add to head. For the add to head, basically there are 4 steps. Let me explain one by one. So for example, this is the node. I'm going to add it to the head. So first step, I'm going to point, this node should point it to the head, and from the tail, it should point it to this node. Yeah, so this is one step. This is step 2. I'm going to finish this 2 steps first. Yeah, so the node dot previous should equal to head. Node dot next should equal to head dot next. Yeah. So the node dot previous should equal to self dot head, and node dot next should equal to self dot head dot next. Yeah, let's see what we are going to do. So this is the only finished one, the first and second step. Now I'm going to connect from the head to this node. Basically this line, I'm going to connect this angle. So how I'm going to connect? So the head dot next, before head dot next connected to this node, but now I'm going to connect it to my node here. So the head dot next should equal to node. Head self dot head dot next should equal to node. Now we only need our last step. We only need to connect from this node to our node. Yeah. So how should we do? Because this node, this connection has already been disconnected, we cannot use it anymore. So we have to use node dot next. Let me check. How should we connect? This we still have this connection. So the node dot next, because we have this connection. So the node dot next dot previous should equal to our node. This is our node. Node dot next dot previous should equal to our node. Yeah. So the last line will be node dot next dot previous not.next.previous should equal to the not. I know it is annoying, but we have to do like that because this is basically what the problem asking us to do. We have to write the very basic data structure. Yeah. At least for Python, we save so many lines of code. For other languages, it might write even like more than 100 lines of code. Yeah. So we already finished this move to head. Yeah, this is we already finished our get function. Now what we left is only the put function. Now let me check. For the put function, similarly, we're gonna do this. If k not inside self.cache, yeah, it's also two steps. If it is not inside, what are we gonna do? We're gonna take this. Yeah, if k is not inside, it means we're gonna prepare a new node. So for the new node, I'm going to use our list node. So the k value pairs, I'm going to take this k and this value. Yeah, this means I've already, for the put, I've already prepared a new node. Yeah, after I prepared this new node, I think I need to connect this node to my doubly linked list. So where should I put? I should put it, for example, this is the list. If I were to put a new one, I should put it at which place? I should, if it is a new node, I should put it next to the head because this is the most recently used. Yeah. Now I would to put it next to my head, and what should I do? I should use self dot. Here I should use add to head because I don't need to disconnect. I only need to add to head. This is why I write an add to head function because I will use it 2 times. So self dot add to head with this new node. At the same time, self.size should plus 1 because I used put a new node inside. The self.size should also plus 1. And we should also update self.cache. Why? Because we need to prepare the cache inside because for every time we are going to check if this k is inside the cache or not. Yeah, so self.cache with this k should equal to our new node. Yeah, basically this is a checking if we can put this new node inside. Yeah, so we're gonna put this new node inside. Yeah, what about the size exceed our capacity? Because here we have another variable capacity. Yeah, we have to check if self.size is more than self.capacity. Yeah, if the size is more than capacity, this means we have to take out one node. For example, yeah, our capacity is 3. Now it is 4. We have to take this out. Yeah, take this node 2 and 6 out. How should we take it out? We have to write another function, move tail. Here I will write another function. It will be called move tail. So here, if self.size is more than self.capacity, this means I need to define another variable. Here I will use removed, and I will call a function self.move tail. This means I will move the node from the tail. Yeah, but the tail is just a dummy node. I need to take the node before the tail. So what is that? It is self.tail.prev. Basically, I'm going to remove this node. Yeah, what should I do? And I'm gonna define this move tail function first. So from here below, I can define my function move tail. And inside, I take a node. How should I move to tail? Basically, I'm going to disconnect a node. Yeah, you see? We also used disconnect node 2 times. This is why I want to prepare 2 functions. One is a disconnect. one is add to head. Yeah. So for here, I can disconnect the node. I will call self.disconnect with this node. This means it has already been removed. And what I'm going to return, I'm going to return with this node. Yeah. Why? Because I'm going to use the k value inside this node. So this is why I need a return with the node. So for here, the put and yeah. So for here, the put we have removed. Removed is the node we need to put. We need to remove, but we need also to update the self.cache. Yeah. So how should we do that? Self.cache with this k self.cache.pop. We need to pop with removed.k because removed is just a node, and inside of the removed we have a k value pair. We can just take this k. This means the k for the cache. We just need to pop this removed.k. Yeah. Now basically, we finished the checking for the exceeding the capacity. Yeah. Now we have another condition. If k is inside self.cache, what should we do? We can just take this node out first because it's inside. Yeah, we can copy this code self.cache k. This is our new node. What should we do next? We just need to, because this is not inside, we do some operations. This is inside, but we also need to, move this node, disconnect. Yeah, we should update the, let me update the value first. So not.val should equal to our value from here, and then we are going to move this node. Yeah, for example, let me, I have to, it takes more time even. I cannot, let me, it's not working here. It's not inside, but basically here, this node value, I update the value of the node first, the first step. And here I take this node out and update this value. And then I just need to disconnect this node and put it to my new positions. And what should I do? I just need to use the move to head function. Self.move to head with this node, but I'm also going to return not.val. Yeah, let me check. I have my node and I've updated the value of the node, and then I move to the head and I just return. Let me check. I don't need to return because this is a put function. I don't need to return. So I just need to update the node.value and then move it to head. Yeah. Now let me run it to check if there are any mistakes. I believe it should have mistakes. Normally so many lines of code. Yeah, self.add to head takes one position. Let me check self. So inside I should always use self because this is a class. Yeah, because this function is just below the class. I should always use self. Otherwise it should be wrong. Yeah. Now let me put the self inside all my functions. Yeah. Now let me run it to check if there are any other mistakes. The removed typo, let me copy the removed. Now let me run it again. Yeah, luckily for me, it works. Now let me submit it to check if there are any mistakes in the all testing cases. Yeah, I hope I can pass. Otherwise, I have to record it again and again. I can never finish it. Yeah, basically the idea is difficult to think about. And also for the implementation of the code is also difficult because at least there are like more than 50 lines of code and nearly 60 lines of code. As you can see, the speed is very fast because everything is just O1 because we use the hash table and we use the doubly linked list, and for every get and put, it is just O1. Yeah, thank you for watching. If you think this is helpful, please like.